I am Faisal and I am currently working as a postdoc research fellow at Web. So have you ever wondered how the face is recognized in a facial recognition system in such a short time? Or how the Google translator, it can translate one language into another language with such a short time? It's due to neural network. So now what are neural networks? Neural network is a type of deep learning which further falls under the category of machine learning. So the algorithms in the neural network, they are inspired from human brain. In human brain, we have billions of neurons that are used to solve complicated or complex tasks. So let us construct a simple neural network. So in neural network, we have input data. The input data is fed into the neural network. In hidden layers, the algorithm learns the futures of the data, and as a result, it predicts the desired output. So before going into detail, let us see the building block of neural network, which is neuron, and how the mathematical calculation takes place in case of neural network. So in neural network, we have an input layer, we have hidden layer, and we have output layer. So let us see that we are given that we have two inputs where x1 value of x1 is 2 and the value of x2 is 3. The weight of x1 is 0 and the weight of x2 is 1. So let us calculate the values of h1 and h2. So at h1, we will have initially all input values multiplied by with its respective weights, and they all are added to a bias value. And after that, we apply an activation function. So let us calculate the value of h1 and h2. So h1 is equal to h2 is equal to f into w dot x plus b. And when we calculate the value, we get f of 3. Now this is where an activation function occurs. So we use the sigmoid activation function, and the mathematical representation of sigmoid function is this. This is simplified version. So when we put the value of x is equal to 3, so we get 0.9526. So now let us calculate O1. So before moving further into detail, let us see what is the mathematical representation of O1. So we will have weights with its respective inputs. So now in this case, we will have two inputs which are h1 and h2, and we apply an activation function and we add a bias value. So when we put up the values, we get f of 0.9526, and when we apply an activation function, so the output value is 0.7216. So this is the mathematical calculation how we can calculate or predict the output values. So let us construct a simple neural network which can classify the diseasable leaves and non-diseasable leaves. So we have an image which is non-diseasable leaves, and its dimensions are 30 cross 30 pixels, and the total value or total dimension is 900 pixels. So these individual pixels, they are fed into input layer. Now the input layer is connected to hidden layer with channels, and we initialize the channels with random weights. So at hidden layer h1, all of the input values with its respective weights, they are multiplied and added, and a bias value is added, and then we apply an activation function. Now what is the role of activation function? Basically, the activation functions gets which neuron should activate. Suppose we have h1, h2, and up to hn neurons. So which neuron will activate, and its data or its inputs will be forwarded to output values. Finally, we have an output layer, and it predicts the output. So in this case, we can see that our proposed model, it has predicted wrong outcome. Why? Because our input was a non-diseasable leaf, and we can clearly see that this has higher probability and it has predicted as a non-diseasable leaf. So initially our model is not trained. So now the training process occurs, and this whole phenomena of feeding the data into forward direction to calculate the output is known as forward propagation. So now let us calculate or define a cost function. So cost function is actually equal to actual minus predicted value. We can clearly see that we already have actual probabilities of the diseasable leaf and non-diseasable leaf. So what we do, we find the error or cost function. So in case of this, the error is actual value minus predicted value, and we have 0.7 error. Similarly, for the second scenario, the error is actual value minus predicted value, which is minus 0.5. So initially in the first iteration, we can clearly see that the loss is higher. The model is now not trained and it cannot accurately predict our input. So after that, based on our cost function, which is mean square error, we adjust the weights in backward direction, and this process is known as back propagation, or the fine-tuning of the weights of the neural network in the backward direction based on the cost function is known as back propagation. So after applying the back propagation, we then again apply the forward propagation, and then we calculate the cost function. So we can clearly see that now after fine-tuning the weights in backward direction, now the prediction of detecting the non-diseasable leaf has been increased. So now it can predict that the leaf was non-diseasable. So in the second iteration, we have seen that the error has been reduced further. After that, we again apply a back propagation in which the weights are further fine-tuned based on my cost function. And after that, I again apply the forward propagation, and clearly after finding the cost function, I can see that my loss has been now significantly reduced. So the whole sequence or cycle of applying the forward propagation and back propagation until my model can accurately predict the outcome, which is whether my input is a diseasable leaf or non-diseasable leaf, is known as training procedure. So now let us see the graphical relationship of loss and weight. As we can see that in the first iteration, my model was not trained, and when I apply a forward propagation and when I calculated the cost function, my error was higher. After that, I adjusted the weights in the backward direction. So after that, when I applied a forward propagation, I can see that my error has been reduced further. After that, further fine-tuning the weights in the back propagation and then applying a forward propagation, the error has been significantly reduced. And clearly, we can see from the graph that there is a relationship between loss and weight. So how can we optimally find the values of weight? This is not that we are randomly varying the weights. So how can we find the optimal weights? There is a technique which is known as gradient descent. It's an optimization technique which is used to find the minimum value of a function. Suppose if we have a graph and its mathematical relationship is y is equal to x plus 5 whole square. So let us start from an initial value, or we can call it as a initial weight. After that, we apply a derivative, and then the value of function is 2 into x plus 5. After that, and another important concept which is known as learning rate. Now what is learning rate? If we define a higher learning rate, our jumps will be higher and my model can fall into a local minimum trap. What is the goal objective of gradient descent? To find the global minimum. If I define the learning rate less value, the jumps will be shorter and I can find the global minimum. So I have defined the global minimum value, I have defined the learning rate as 0.01. So now let us see how we can find the values of new weights in the back propagation. Already I have previous value x0 is equal to -3, learning rate is 0.01, and when I apply the derivative on the equation, I get 2 into x plus 5. So when I put up the values, I get the value of new weight as -3.05. Clearly, I can see that I am moving in the right direction towards global minimum. Clearly, if I define a higher learning rate, this jump will be higher. So let us apply a second iteration and see what is its effect on the graph. So my previous weight or previous value is -3.04. So when I put up the value, clearly I can see that my new value is -3.0792, which is near to my global minimum. So this whole iterative cycle of finding the optimal value of weights is known as gradient descent, and this is objective of the neural network, that how can I find the optimal value of weights to reduce the minimum value or reduce the loss function. So concluding the presentation, I discussed the basic of neural networks. Then I tried to explain the back propagation and forward propagation by giving an classification example. After that, I tried to discuss the gradient descent, which is a technique used for calculating the optimal weights. So I hope you would have liked my video, and thank you for watching it.